stuff over. All right, so hello and welcome to the virtual Kansas City SQL Server User Group Lunch and Learn December edition. Thanks everyone for joining. We are happy to welcome Dejan Sarka to our user group today, presenting the all-important topic on every BI person's mind, optimizing ETL on the SQL Server side. I know this is a constant topic that's brought up at our company. For our US folks, this may be a lunch and learn, but don't feel left out if you're joining us from somewhere else. Feel free to have any meal or perhaps a midnight snack, whatever accommodates you. For the audience, this session is recorded and will be uploaded to our YouTube channel. If you have any questions, go ahead and pop them into the chat and I will direct them. As usual, with our lunch and learn, we jump right in. And with that, I will let you take it away.
Great, thank you very much. So thank you everybody for joining. Before I even start sharing the screen, let me just mention that I have already sent a message to chat with a link to the material, all of the code for the demos and the presentation. And of course, the presentation is also recorded. But with the material, you will be able, of course, to taste everything by yourself. Anyway, so let me share the screen. What's wrong? Okay, now I guess you see my screen. And just somebody confirm that you see my screen.
I see it.
Yeah, thank you very much. So we can start with the presentation, optimizing ETL on SQL Server side. As Christina mentioned, I am Dejan Sarka. I am, of course, from Europe, from Slovenia. I'm currently at home, so it's 7 p.m. for me, but I'm really glad that you are spending your lunch break with me. And I am pretty long in this business. I co-authored 20 books so far, many courses, and I focus on SQL Server, business intelligence, data science. So I will make a brief introduction to this presentation, and then I will talk about optimizing ETL from these perspectives, finding the delta, optimizing staging tables, what does it mean to disable indexes and constraints, and mention table partitioning. Now, even before I start, I would like to say that I wanted to make this presentation somehow different than usually the presentations are. So not just mentioning what is better, what is worse, but I also created a complete infrastructure for measuring many things, for measuring the impact of different methods of extracting the data, finding the data, impacts of, let's say, minimally locked inserts or compared to trickle inserts, and so on. Let me start immediately. Now, optimizing ETL starts on the source. And the problem with the source is that these are typically line of business systems, which are already utilized heavily. So with your ETL, you shouldn't put too much additional burden to these systems. And first, optimization is to find the delta, find what has changed from the last load. And we have many options how to find this in the source. So we can use data modification language triggers, after triggers, to archive the changes. We can use output clause in the insert, update, delete statements. We have change data capture possibility. We have change tracking, which was introduced as lightweight change data capture. We can even track changes in system version or temporal tables, or we can use raw version data type column. And I want to compare these methods and see what is the impact on the source. So we are here in the full business BI intelligence end-to-end solution. We start with data sources, and then we'll go through staging area to data warehouse. We are not going to talk about Power BI, optimizing data models and reports, semantic models in reports in Power BI in this presentation. And let me also show you the infrastructure. There is a lot of code, but I will just show it. I already executed it many times in advance, so I have measures already prepared. I have averaged these measures, so they are quite reliable. Anyway, I created a new database, and you will see that it's really a lot of code, and it would be also, it would consume too much time to execute all of this. So I created two tables. Maybe I can just show you a simple database diagram. So I have customers and orders connected with a foreign key. So this is kind of scenario. I will track changes in both tables, and I fill them with, let's say, little bit more than regular demo tables with a little bit more of data. So I will show you the content of these tables, and then I also copied some data into auxiliary tables that I will use for these DML actions. So what can be, what actions can happen? We can have, of course, insert, update, and delete on orders, insert, update, and delete on customers. And in both cases, we can have single row operations, or we can have batch operations operating on multiple rows. So altogether, 12 different things can happen, like batch delete on orders, batch delete on customers, trickle delete on orders, trickle delete on customers. So I will use auxiliary tables, one for each, for delete and insert for each source table. So first I will delete and later insert the same rows, and one for updates. Please note that I have already properly indexed all of the tables. So let's see what is the content, and you will see that we have quite a lot of data. So even just this simple select star from table will take us some time. So from customers, I have nearly 100,000 rows. Let's see orders. This is slightly bigger, so it will take like 10 seconds or a little bit more to read all of the data, but I will not execute the code later because, as I said, it would be too intensive for the presentation. We would need a couple of hours to get through all of the demos. So we have like nearly 1 million rows in orders. And then I have some rows that I will delete and later insert. For customers, I have 2,000 for delete and insert, and I have 2,000 for update. For orders, I wanted to have something around 10 times more, 20,000, but of course I had to select rows through foreign keys to have the correct rows. Otherwise, things wouldn't, for delete and insert, otherwise things wouldn't work. And then I am measuring DML performance with different settings. So I have results where I will check what is data type, and first it is elapsed time in milliseconds. And then I will have summarized result for each type of delta tracking, where I will track CPU time, reads, writes, and logs that all of the actions needed. And I can get most of this data from dynamic management objects, but logs I can get through extended events. And that's it. Start the session, write down the first piece of data, right? And then do the modifications. And first, this is just first SQL code file out of 7. First is regular deletes, updates, and inserts without any change tracking. So I have the baseline without any change tracking. And then, of course, this is quite a lot of code. So I'm doing through cursor some trickle inserts, trickle updates, and with set-oriented statements, I'll do this in batches. And then, of course, when this is done, I have first partial result for, let's say this time, for actions without any change tracking, right? And then I have another file. I will just show these files. And I have another file for following DML after triggers. So I create archive tables, add triggers to source tables, and then I repeat all of these actions, insert, update, delete, with tracking logs, reads, CPU time, writes, and elapsed time, right? And then I have one more file. You see, these are quite big files. Let me just go here and show you in the folder. Delta 3 is the output clause. And then I have delta 4. I will just open it quickly with Notepad, it's faster. Then I have change data capture file. And then I have delta 5. This is file where I implement change tracking and measure again all of these actions. And then sixth one is temporal tables. So creating temporal tables and storing data there. And finally, I also use a raw version. And then, of course, I got these results. I will just show you now the results and then also the results in some nicer format. And then I will comment these results. So first, let me find the results in table while my Power BI file is opening. So I have summary results. Let me just select this. So I have summary results. You see for these 7 options, non-tracking delta type with the trigger, output, CDC, change tracking, temporal tables, and raw version. And these are starting and ending values. And here we have totals. So it is altogether CPU time, reads, writes, and logs. And this is for all 12 actions, trickle deletes in both tables, batch deletes in both tables, trickle updates in both tables, batch updates, and trickle inserts and batch inserts in both tables. And then I have detailed table with just elapsed time. So we have 7 times 12 rows, for 12 actions with different delta types. So we have altogether 84 rows. So for none, and then for trigger, trickle, delete, and so on. And you can see that there are some differences. Now I already created a nice Power BI presentation of this. So we can just go to results and then I will comment what happened. Now be prepared, results might be somehow surprising. So probably everybody knows that triggers are problematic because transactions become longer, so we have more locking. For example, change tracking is somehow lightweight change data capture, etc. Okay, but let's see. So let's start, let's say, with CPU time. So I have this parameter for the measure. And you see, this is sum of CPU time. And of course, the lower bar is for without any tracking. Raw version is, of course, very, very lightweight. This is just an additional column that is automatically updated on every update and inserted with insert. One unique value for the full database. So it's really nothing much added to the tables. So of course it's the second best. Turns out that CDC, change data capture, is quite efficient here. Temporal tables as well. Trigger is not the worst. Change tracking somehow isn't so good as change data capture. It didn't turn out that it would be a very lightweight solution. And look at which one is the worst. The worst is output clause. Output, I don't know if you are familiar with it. Let me just go to the documentation. This is how it looks like, right? So you add output clause to every single insert, update, delete, and you can have output directly to the client or output into in some archive table. And I am, of course, doing output into, so I can read data from the archive table. And during the output clause, you can refer to the inserted and deleted tables, similarly like you can do this in a DML trigger. But there is slight difference. In a DML trigger, in both tables inserted and deleted exist after every single action, insert, update, delete. Just after insert, delete, it is empty. After delete, insert, it is empty. Here in output clause, during the insert, deleted table doesn't exist. I would get an error if I would, for example, here in this code, replace inserted with deleted, and during delete, inserted table doesn't exist. Anyway, let me go back to my Power BI file. So CPU time output clause was really bad. And of course, you can imagine immediately why is also this output clause very bad, because you have to change every single insert, update, delete. Now think of it. You are tracking changes in some existing application, so it would mean probably rewriting the complete application. If you start writing application from scratch, maybe it makes sense. This output clause was introduced in SQL Server 2005, but somehow doesn't look that it would be extremely efficient. So let's check the elapsed time. And again, you can see output clause is somehow the worst. Also, change tracking doesn't look too good. Trigger not that bad, change data capture efficient, especially for elapsed time. Temporal tables are extremely efficient, system version tables. Let's check logs, right? And again, output is pretty bad, but also here change data capture made a lot of additional logs. In this case, trigger was better than change data capture. Again, temporal tables are very efficient. Row version, okay, yes, this is very small modification, so it's practically the same thing as not following or not tracking the changes. Logs change tracking looks extremely efficient here, even better than without any data tracking. Of course, there is one more thing. With change tracking, you have to use snapshot isolation. Change tracking works with snapshot isolation. So again, you have to do some changes in application. At least it's not like with output clause where you have to change update every single insert, update, delete statement. Here maybe right after the start of application, right after you connect to SQL Server, you set transaction isolation level to snapshot. Still, it means small change in applications. Writes, of course, without any tracking, and with row version, we have minimal amount of writes. Again, temporal tables were pretty efficient. Trigger was efficient. Output, change tracking, CDC were not very efficient. Do we get some additional reads? Like in the first moment, you would say, I don't need any reads since I'm just tracking what happened. And you see, some things, non-row version CDC do not have any additional reads. Trigger might have some additional reads and output and temporal, but change tracking made a lot of additional reads in my tables. And here is the details table, like elapsed time for all different methods. So of course, I can now sort this according to different numbers, and I can see some, let's say, facts. For example, trickle delete without, here I have at the bottom none. So trickle delete took 3 seconds. This is in milliseconds. And for example, in the upper row, I have trickle delete with output clause took me 10 seconds. Trickle insert 15 seconds. Change tracking, you see trickle insert is even worse. And remember, these are already averaged measures. Now I can go back to slides and compare these things. Of course, DML triggers we know we have these inserted and deleted tables. We know that transactions become longer, so we are afraid of additional locking time and additional locks because of triggers. Well, it turns out that they are pretty efficient. Well, output clause in my tests came out that it's completely useless. I mean, first of all, who will completely change all of the inserts, updates, and deletes in an application to include output clause everywhere, right? This would make sense only if you start writing new applications. But also, interestingly, since this is not something like trigger that should be triggered separately, it's part of these statements. I would expect that it should be more efficient than triggers, but according to my measures, is not. Change data capture was pretty efficient. On the bad side is that disadvantage that it is enterprise edition feature only, but it has also some other advantages. First of all, there was no change in code, right? And it is asynchronous, so impact on transactions is lower than with triggers or output clause. And also it works. We have changed data capture also for Oracle, not just for SQL Server. So the same technology can be used if you have different database management systems in your environment. What else? If you use integration services, we have already tasks and transformations that mitigate data with change data capture. You are getting these changes through system functions and additional system tables that are created when you set up change data capture. So let's say it's slightly more complicated than using triggers output clause, where you find data in tables that you defined for archive. Change tracking declares as itself as a lightweight solution compared to CDC, reads the transaction log, right? It tracks only the fact that a row was modified, not all modifications. Therefore, you must have a primary key. By the way, one small thing with change data capture, you don't need primary key on tables because it really tracks all of the changes. Of course, not having primary keys in a production system is a very bad practice, but just worth mentioning. With change tracking, you can track on column level. The latest data, you can find it in source tables, but it works with snapshot isolation level. And I will not go into details, but it's pretty complex also to find the data, and especially to restart it. If you have some problems with it, many times you have to start from scratch to make an initial copy of data. I really love this solution, system version temporal tables. It's simple, it is efficient. Of course, the last data is in current tables, but all updates and deletes with validity, exact time when these updates and deletes happened, are stored in history tables. You can use default names, default structure, which is, I think, page compression, or you can make your own system tables. And default is row store with clustered index on these period columns. Very simple to use, and for querying, we even get some additional for system time clause in the from part of a query. So it's pretty efficient, also simple to use, and could be also used to find the data directly in the source system at specific time point. You know, you query the current table, and you say for system time as of date time, and SQL Server will find rows either from current or from history table, valid values on that specific time point. So besides these temporal tables are useful for tracking changes, they can be also useful in this line of business systems to find the state on any specific time point. Row version is of course extremely efficient since this is just a single additional column. Okay, you must manually determine the DML operation, what happened, insert, update, or delete, right? And maybe one small thing, with temporal tables, you have to add two date time, two columns for begin and end of validity period of the row, and you can hide them from select star. If your application is not written very well and uses select star, you can hide these two columns so they will not appear in the output unless you explicitly call them, unless you explicitly list them in select list. You cannot hide row version column from select star. So this might be also an obstacle for implementing this solution. Otherwise, it is very efficient, very fast, of course, since the changes in source are very, very small. So altogether, I would recommend definitely temporal tables, definitely a row version, okay, but there is modification that adds a column which cannot be hidden. Triggers doesn't modify structure and are pretty efficient. So probably, as I say, I would recommend temporal tables before row version, then maybe triggers, and definitely change data capture before change tracking, or maybe even better said, I would not recommend change tracking and output clause more or less at all. So this may be summarized in a couple of slides. We don't need to read this again. Okay, so now we have read data from the source. What is next step? Next step, you typically store this data into some staging tables for fast load. And of course, in these staging tables, you are not very interested for logs and these things anymore, since you are already in a single user mode when you are doing this ETL job overnight. So you can actually use table logs. So maybe the only really important thing is here is elapsed time. Also, these staging area tables can be these temporary tables, or you can also use in-memory tables, right? Since these tables are typically truncated before each load, before new load in the next night, when the data from previous load is already transferred to regular fact tables and dimensions. So basically, we are here, right? And we can also use, as I said, since we don't need to persist this data, after ETL is done, tables can be truncated. So we can also use memory optimized tables. So these tables initially were introduced in SQL 2014. Big improvement was in 2016. Initially Microsoft targeted transactional processing workloads. However, turns out that they are not frequently used there, but they are quite frequently used for ETL staging. Basically, they don't have so many functionalities like on disk tables, and this is problem for already developed applications. But the design goal was performance rather than functionality. They have new in-memory row and index structures. We don't have any locking. We have only this optimistic approach with multiple versions, and we can even natively compile stored procedures that work with these tables. So let me just show you the code that I used for this one. Okay, now I can close some of these queries, and let me show you the code. Now I have one file for every step, not 7 files anymore. So I added file group for memory optimized data, and then I created 8 different tables. 2 regular disk tables, 2 temporary tables, not temporal, but temporary in TempDB, and 2 pairs of in-memory tables. In-memory tables, so one pair has durability schema in data, so data is asynchronously hardened in a disk in a file stream asynchronously after it's already there, and another pair that is schema only, so data is not hardened on the disk at all, since what does it mean? If SQL Server restarts, the data is lost. But we are here in the staging area, we don't need to persist this data. And then, of course, I created a separate table for the results. And for these 8 tables, I compared trickle inserts and minimally locked inserts. So I do like 100,000 trickle inserts, and then I do minimally locked inserts, right? So, and then I compare and save the results. So let me show you the results, and I have these results also on slides where they will be easier to read. So let's now compare these solutions. Look at difference between trickle and batch inserts. With on disk tables, we went with those 100,000 rows from 2 seconds to less than half second. Temporary tables in TempDB, the difference to regular disk tables is not very big. I have the same disk, physical disk for both. It is an SSD, but okay, this is fair comparison since we use the same hardware. Now look at in-memory tables. Trickle inserts are not so much faster as trickle inserts in regular disk tables are. If you use trickle inserts, since you are doing this in overnight batch jobs, maybe it doesn't even make sense to complicate with memory optimized tables. The single most important thing here is to do batch inserts, minimally locked inserts. This is the single most important thing, you see. Then we have immediately much lower numbers, and definitely if you look at the last number, minimally locked batch insert in the in-memory table without data hardened on disk with persistent schema only, we came on less than 1/20th of initial time, from more than 2 seconds to 94 milliseconds for inserting 100,000 rows. So now you have the idea. First important thing is not to use trickle inserts. First important thing, the most important thing is use minimally locked batch inserts. Otherwise, staging tables are not too complex, right? And then next step is load from staging tables to dimensions and fact tables, right? Here in this point, when we load these tables, data should already be cleansed, right? And we have primary keys and foreign keys. We have foreign keys from fact table to dimensions. And remember, foreign keys do not create indexes automatically. Now, what do we need to compare here? Again, we are doing this in single user mode, so we do not care about locks. We have our own overnight process. So again, the real important thing is elapsed time. We also, since we are doing more or less overnight in a job when we are alone, we can also use all CPU power we have. So really, elapsed time is the only really important thing that is interesting. Now let me show you the script and comment it a bit. Okay. So what do we have here? Now I'm using AdventureWorks DW demo database, right? and it has some data for a couple of years. So I'm checking what are different dates in different fact tables. Okay, first of all, let me execute also the use statement. So some have more years, some have less years, but we have years from 2000 to 2010 to 2014 mostly, like fact internet sales has 11 to 14, right? And this is the range of data, right? And we have ship dates, and we have order dates, and we have due dates, right? And let's check what dates do we have in dim date. So we have dates from 2005 to 2014. So now what I'm testing is, let's say that I want to delete these early years from dim date. This is one option. And I have foreign keys. And then I have also inserts in both tables. And I could also have deletes from fact table for some reason. So I am using first initial structure where, let's go to this AdventureWorks database, DW, right? I have diagram, for example, internet sales, right? So what I have here is, let's zoom to 200%. So I have some fact table, fact internet sales, which is 3 times connected to the DBO dim date. And of course, dim date is the most critical dimension since it is connected to all different fact tables. So we have order date, due date, ship date. And defaults are used. What are the defaults? Remember, primary key, like in dim date, date key creates an index. However, foreign keys do not create indexes automatically in our fact table. So we have this scenario, and what did I test? So I test default. We have foreign keys without indexes, and we are deleting from dim date, and then of course rolling back and checking the results. Let me just show you the table with, okay, it's I would have to create it, but I will just show you the results. So show the results on the slide. So what is happening here? So we are here from staging area to data warehouse, and here are the results. Remember, default is this. Default is we have foreign keys, but we don't have indexes on fact table. So I'm doing delete from dim date, and I deleted a single year, 365 rows, and it took me practically 1 minute. You see, 57,000 milliseconds. What is happening here? Well, this situation is extremely awful because of foreign keys, we have to, of course, check before we delete every single row. We have to check if they are associated rows in fact table. So for every single row, I'm checking fact table without an index. So I'm doing scan. And dim date is connected to many fact tables, some like fact reseller sales or fact internet sales, also with 3 foreign keys. Please note that these tables are still very, very small. So I think the biggest is fact internet sales with 60,000 rows. Of course, with millions of rows, this could take days, this option. So this is definitely not an option for production. You see, this is definitely something that you don't want to do. Is it very, very dangerous? Well, it's not very dangerous because think about real life, how many times you will actually really delete rows from dimension date. You typically have rows for 10 years, and then maybe once per year you add, or maybe even more rarely, maybe once per 3 years, you add new 3 years for the future and delete last 3 years. So definitely it's not something that you would do daily, But before you do it, please remember defaults primary keys with indexes. Foreign keys are by default, do not create indexes. And then I actually deleted 5 times more rows, 5 additional years, but I created also indexes. And now you see we have index seek for every single row that I delete. Look at this, more than 1,000 times faster, but also 5 times more rows. So it's like more than 5,000 times faster. Of course, we are doing index seek instead of scans, and the difference with larger fact tables would be definitely even a lot higher. So what does it mean? If you really have to delete things from dimensions, do not forget to either index fact tables, or the other option, even faster, temporarily disable foreign keys, right? This is even the fastest option. What about inserts? Inserts are not problematic. Regular, so this initial schema is we have foreign keys, right? And we don't have indexes. No problem, right? Because when you insert in fact table, you do index seek to the dimension table, since we are using primary key in dimension table, which creates an index. Now, if you look at this second part, let's say that you have a regular, that you have now index on the foreign key on fact table. So suddenly inserts are nearly 4 times slower, at least with this data. Again, I would say difference with larger tables would be even worse. Of course, now when you update fact table, you also have to update the indices, you see? And suddenly you might have many indices. For example, just to dimension date, we have 3 foreign keys, so we could have 3 additional indexes, let's say, from fact internet sales table to just a single dimension. And I indexed really just indexes for dim date. Now we have also other dimensions. So you see, in these defaults are not bad at all. You definitely do not want to have indexes on foreign keys in fact table, because these inserts would really significantly slow down. And this inserts is something that you do every day. So this delete is not so problematic because you do it, let's say, once per year or once per 5 years, whatever. Just don't forget to index the fact table before you delete dimensions, and then simply drop the indexes. Okay, the fastest is, of course, even without foreign keys, since you don't have even index 6 to two-dimensional tables. So I see defaults that are also in demo databases are selected pretty well. Suddenly you realize that it makes sense that foreign keys do not make indexes automatically like primary keys or unique constraints do. Just one thing to remember, these defaults are pretty decent. Okay, without foreign keys, everything is even faster. Great. But foreign keys are really nice, since they can be also inherited in semantic model in Power BI. It's easier to understand the graphs, diagrams, entity relationship diagrams if you use foreign keys. So easier to document your data warehouse. And as I said again, seems like these defaults, primary keys for dimensions with indexes, foreign keys for fact tables without indices, are very well selected by SQL Server team. The only thing to really remember here is, before you start deleting in dimensions, don't forget or maybe deleting or maybe even updating keys. Please, this is extremely bad practice. Do not do this. But also updating primary keys in dimensions would be awful. But before deleting rows in dimensions, don't forget to either disable foreign keys or index them, and then don't forget to drop the indices, because otherwise you would get much slower inserts in fact tables in every single daily load. And although, as I said, in this slide, this number doesn't look too bad. Remember, these are then small fact tables with I only added 3 indexes to dim date. You could have even more indexes. And this is something that happens every day. This number looks really, is kind of really scary, right? But remember, this is happening once per year or once per 3 years, so not big deal. Just don't forget before this action, index for foreign keys and then drop the indices. Now, the last thing, so I don't want to be too long, but remember all of the code you are seeing here, you have in that link that I have shared in my OneDrive, so you can start playing with it later, or you can even use it. You can replace my inserts update deletes to my test table with actual insert update deletes like they would be in your data warehouse and measure that, right? Anyway, the last thing is table partitioning. Now, this table partitioning is enterprise edition only, right? But for data warehousing, you can even do some kind of manual partitioning, and you don't need the enterprise edition. Table partitioning is useful also for transactional scenarios in a different way than in data warehouse. So how is it used in transactional scenarios? In transactional scenarios, you typically create a partition with hot data that is updated frequently, but we have small partition and then we have archive partition with stale data, and typically this archive partition is in another file group and might be very huge, this other file group, but since this is read-only data, it doesn't need a lot of administering. So you have maybe once per month DVCC check file group. Since it's read-only, you don't even care if it takes a couple of hours, but full DVCC check DB would be simply too long. Also, backup full database, the backup would take too much time, but you have to, let's say, backup these archive partitions maybe only once per month when you load data from previous month from the smaller current partition. And the current partition is small, so you can do more frequently check file group if it's in own file group, and you can also use do more frequently backup of the file group, right? How is this useful in data warehousing scenario? Now imagine that for some reason, maybe some DBA will tell you not in my house, right? You cannot implement any of the finding delta solution we introduced in the beginning. Maybe for some reason, some DBA say, okay, I do not allow this. Now you cannot really afford to transfer all of the data for, I don't know, 5 years every day. So how can you help yourself here in a data warehouse? Well, even in transactional systems, there is always some data that is not changing anymore. Of course, we have this concept of fiscal year. When fiscal year is closed, you do not update data from the past anymore. Of course, at least you don't want to mess with tax authorities since you already declared taxes. So what does it mean? So in data warehouse, you create partitions. Practically, you need to only for current data and for archive data, but maybe you can have for every single year own partition, right? And then data for current data is loaded into a new table with the same structure, just it must have a check constraint that guarantees that all of the data goes when it will be moved to the fact table in a single partition. And since this is a table where you have all of the data for current fiscal year, you can every day start by truncating it, which is minimally locked operation, and then read the current fiscal year from the source system. Of course, it's more reading than finding the data, but still it's one select, right? And load everything in this new data table with batch insert. So let's see the code. And since this is not too much code and not too will not take too much time, I will just execute it, right? So I have internet sales over here. So you see, I have internet sales here for 5 years, but 2019 has only 14 rows and 2023 has also not so many rows. Anyway, I will create the object. So I will create internet sales table and internet sales for new data. And then I will create partition scheme and partition function. So partition function is like semaphore guiding rows to partitions. So I have partition for year 19, 20, 21, 22, 23. Range left means that this 19 is in the first partition still. Range right would be up to 19 in first partition. Partition scheme is mapping partitions physically to file groups. In transactional system, you would have multiple file groups here. I don't care about backups, integrity checks so much, so everything will be in a single file group. And then I create internet sales, just this time with additional partitioning column, right? And this table is now created on partition schema, not on file group directly, but on partition schema. Now I will load years from 2019 to 2022 to this table, and my new data table has completely the same structure. Just please note that I have additional check constraint that guarantees that all of the data will fit, all of the data in this table will fit into a single partition. So now let's do this regular daily load. I'm inserting data that I read from the source, right, for the current fiscal year. And I'm inserting data into my internet sales new table. Let's check data in internet sales and internet sales new. Let's check. So I have 4 partitions with 4 years in internet sales, and the last year is in internet sales new. And now, since here is just a single partition and check constraint guarantees this, I can just switch partition to internet sales. So it means I'm assigning all of the data from internet sales new to a single partition in the internet sales facts table. And this is extremely fast. Let's just execute. You see, it was like in a couple of milliseconds. Okay, there are not too many rows, but still. So this is kind of operation that is updating index allocation map pages only. Simply, each table has IAM pages that point to extents which belong to the table. And if all data goes to a single partition, then SQL Server can do switch without deletes and inserts, simply maps these IAM pages for internet sales view new, that these extents do not belong to this table anymore. So change this bit that points to extent to 0, and the bit that points to the same extent in the IAM page for internet sales is then switched to 1. And suddenly the data in internet sales, the last year is internet sales. Truncate is also minimally locked operation from, I think, 2016 or 2017. You can use also with partitions. So I can also use this sliding window scenarios. I deleted data from the oldest partition. Now let's check data in both tables again. So you see the oldest partition with, I think was year 2019 with 14 rows has disappeared. New table is empty, and last year is internet sales. Now, as I said, what if you don't have enterprise edition. If you want to use partitioning with transactional systems, definitely go to enterprise edition. Also, log escalation will not go from row to table, but will go from row to partition. Here for data warehouse, you can do this like poor man's partitioning, manual partitioning. So I will create 3 tables: internet sales old, internet sales current, and internet sales for everything. So let's create these 3 tables. Let's create these 3 tables and immediately, so I will immediately load them with data, right? Now, new data table. Please note that I also, so this is like for current partition. And I will load the last year to this new data with minimally locked inserts. And then I will create a view that will simply union everything from internet sales and with current data. But let's check the data in the view, you see. So now I see all of the data together, although physically last year is in a new data table. And since this can be emptied, this can be truncated every day, also can be also then loaded with minimally locked inserts. But remember, I have another table for all data. So let's mimic first daily load. I simply truncate this current data and do the insert again. Just this time, just to show the difference, I will do the same insert twice. So I will simply have more years. So you can see view simply shows me double the amount of rows in new data table. Now, why did I also create one additional table? In case I would need to truncate a partition, I cannot truncate here since this all data is in a single table. So all I have is truncate table. I don't have partitions. So what would I do? I would simply move this data to an archive table, right? And this way, this would be more long-lasting operation. But anyway, in a data warehouse, you can mimic table partitioning without enterprise edition. So we will hear from staging area to data warehouse. We saw this. Please note that if you use indexes, they should be partitioned in the same way as tables. So you should have partitioning column in every single index. These are then aligned indexes. If you have multiple indexes that are not aligned, that then partition switching is not metadata operation only. Also, table partitioning is useful for query optimizer. If you do manual partitioning, of course, you don't have partitions, you have different tables. But query optimizer also knows the borders of partition intervals, so it can also use it for optimizing the query for early partition information. And you can simply implement this sliding window scenario. You have multiple partition, truncate table with the old partition, and load data in the new partition. And I guess I just used my time. Are there any questions? I see the chat. Oh, thank you very much. Very, very nice remarks in the chat. Let me just check if there is also some question. You can also turn on microphones and ask questions.
Didn't see any questions. I kept an eye out for them, so I didn't see any come through. But just a lot of comments on how great and detailed the presentation was, which I absolutely agree. I'm so excited about those files you included, and I can't wait to kind of play around with them on my own and see what I can see.
Okay, great. Well, thank you very much for this positive feedback. I'm also very happy and really thank you for spending your lunchtime. This is great. You have a break now. You have to work again. I don't have to work. I will have a beer now.
There you go. There you go. I think this too is really, I was just thinking as you were going along in the beginning too, how helpful it is because it gives you kind of, those reports give you a kind of a database evidence that you can bring to other people to justify, hey, yeah, we need to make these changes. And we don't often have those real live justifications that we can show upper management of why we're kind of making some technical cleanup. So thank you again.
You're welcome, and thank you for having me, and hope you will have many, many good presentations in the future.
Thanks so much. And thank you everybody for joining, and we'll catch you next time. Bye.
Bye.